Alright, so my latest printer, I don't know what I'm going to call this thing, but it is printing, finally. I need to dial in some settings, but overall I am pretty happy with the results of this as it stands. So it probably doesn't look much like a printer other than the fact that it is actually printing. So this was purposely made out of a lot of recycled parts. If you follow Printerstein videos, you know that it's all about recycling and upcycling. So this is what I started from. This is I don't know what it is, but it's got a DC servo motor and some linear bearings, a lead screw. This platform moves up and down, a lot of other sensors and such on it, but I wanted to use that as a starting platform for building a 3D printer. So this is what I end up with. It's a little haphazard. I didn't really design this on paper. I just started building and decided to see where I went with it. And it's a little clumsy. A lot of things are stuck in places, like this little stepper driver board over here, where I just ran out of room on this thing. So it is what it is. It works. I'm happy with it. So the selling point of it, well, I'm not selling it, but you know, the main point of it is that I used as many recycled parts from other pieces of equipment that people donated to me, things that were in the e-waste bin place that I work. So I've got things like this banner sensor right here that I'm using. This is a fiber optic reflective sensor, and it exits right there. You can kind of see the red light coming out of it. And when I home the Z, it looks for this little piece of reflective tape here. And I've got a slotted optical sensor here. I've got an Omron sensor down here that is looking, you can see the reflective sensor back here, and it's just looking for the edge of the bed when it crosses over that sensor. Things like that. I used those 12 volt output signals because they're all 12 to 24 volt industrial sensors. Made this little interface board that's just voltage dividers with resistors to turn 12 volt signals into 5 volts, so I can feed that back into my controller, in-stop inputs, and I'm just using a standard Mega Ramps 1.4 combo with some additional tweaks I made in the G-code to make things happen. I had to buy some things like that. I bought this bed MOSFET driver for the heated bed, you know, the extruder and the hot end, things like that. You have to buy some of that, but a lot of it isn't. A lot of these, you know, linear bearings on the X and on the Y, those were salvaged from used equipment. The case for the display is just some acrylic pieces that I cut and drilled and tapped to make this little box for that. And I stole, this is like the one thing that I actually downloaded to print, was this Prusa knob, which I really like. I just happen to like that one more. But I've got, you know, drag chains that I took off of other pieces of equipment. And I've got this bearing over here, that's idler bearing, is from a hard drive. And, you know, this sensor is from, I don't know what it's from. So I couldn't even tell you where a lot of this stuff came from because I'm a bit of a pack rat. And I save all this stuff until I need it. You know, this piece of aluminum was just a piece of scrap. There's a NEMA 23 driving the Y-axis down there. So I'm going to walk through a little bit of the operation here, but otherwise that is what it is. That's what it looks like. That's how it operates. Again, not your standard 3D printer like most people would build, but I'm not going for that. So if I walk through a homing sequence right now, you can see right now this is my Z sensor, and the fiber optic ends here. You can see the little red shining through there that reflects on the rod, but it's looking for this piece of tape. So when I home this, so this sensor is picking that up, and the same for the Y-axis. That there's my amp, and back here is my sensor, and as I move the bed, it's just looking at the edge of the bed. So if I want to home my Y, it does that. Same with the Z. There's just a reflective slotted sensor here, and I made a, whoop, too far, made a little flag to move up into that when it homes. So here's something that I built into this, and this is my design, and it is a tactile bed sensor for bed probing. And what it does is I've got a slotted optical sensor here, you can see the red light, and I've got this flag for it, but I've got magnets on either side of this, and I've got a magnet inside this flag as well, so it's pushing against these two side magnets. If you push it far enough, it pushes past that point and then drives the other direction. So now I've got a flag that latches in one of two positions, and you can see that when the flag moves up into the sensor, it activates that. So I've got an interesting way, well, I think it's interesting, way of activating that. So I'm going to run through a little homing routine here that uses this motor and this arm to activate that probe arm there. So it homes, it deploys the probe, and then it goes down and maps out the bed. You can see the light on the optical sensor. So I'm just using 9-point. I like to use 9-point when I've got a removable bed, which I do. So now once I've got the probe in place and I've mapped, I've got to get it out of the way. So I designed this so that when you go to Z0, that it automatically pushes that probe back up. You can't bring the nozzle down to the bed without the bed or the probe undeploying back up to the storage position, so you can't forget about it. So that's one of the things that I designed into this. I try to add a new feature every time. This whole thing, it's just a 28 BYJ 48 stepper motor, nothing special. I'm driving that through an A4988 driver and using the step signal from a 555 timer board. I was going to build one, and these are like $3 on Amazon, so I got lazy and I just bought some of these. But that's my step pulse, and my enable and my direction come from my AUX 2 connector here, pins 40 and 42. I'm doing all this in G-code. All of this bed probing is part of my starting G-code, so I didn't have to rewrite any Arduino code. So hopefully that's interesting, and hope you enjoy it.